Welcome back to Concepts in Arithmetic. In this video, we are going to actually talk about two related concepts, that of finding the greatest common factor of two numbers and the concept of least common multiple of two numbers. Now, both of these concepts are related to the material that we discussed involving factoring numbers into primes. Okay, so we're going to build on what we've done in the previous couple sections. So just so we're all on the same page, the greatest common factor of two numbers is the largest number that divides into both of them evenly. So let's start out with an example here. So the question that we're trying to tackle is finding the greatest common factor of 36 and 54, and usually we just abbreviate GCF right there. GCF of 36, 54. Okay, so here's one way to do this. Okay, we're going to list out the factors of both numbers. Okay, now we remember factors come in pairs here, so 1 is a divisor and it's paired with 36. 2 would be paired with 18. 3 would be paired up with 12. 4 with 9, and 6 is paired up with itself, right? So I've listed out all the numbers that divide into 36 evenly. I'm going to do the same thing for 54. Okay, so I've got 1 and 54. That's even, so it's going to have a factor of 2. The partner is 27, right? 2 times 27 gives me 54. That is a multiple of 3, right? If we do our divisibility test, 5 plus 4 is 9. So 3 divides into this number. 3, and the companion is 18. Now this is not divisible by 4, okay? You can do a test there, quick long division. 4 does not go in evenly. 5, no. 6 is going to be a yes. Whenever something is divisible by 2 and 3, it's going to have to be divisible by 6. So 6 is paired up with 9. So if we look at both lists, we can see what the common factors are. We have 1, 2, 3, 6, 9, 18. So the greatest common factor of 36 and 54 is 18. Okay, once again, I am in the way. Yoink. Let's go over there. Okay. So, that is a pretty straightforward way of doing the problem. However, you can see it would get kind of tedious if the numbers were bigger and had even more factors than 54 and 18. So we're going to talk about two ways to get the answer faster. Okay. So let's call this, so I don't know, the prime factor method. Okay. So we know how to factor these things. 2 squared times 3 squared. If I were to factor 36, let's say doing a factor tree like this, right? 36. It's 4 times 9, we know, and that's 2 times 2 times 3 times 3. And these are primes down here. So the prime factorization of 36 is 2 squared times 3 squared. Now let's look at 54. Okay, we could also do a quick little factor tree for 54. Okay, this is 6 times 9, 2, 3, 3, 3. Okay, so this is 2 squared times 3 power 3. Okay, that's the prime factorization of 54. Now, when you've got the prime factorization, you can build your GCF. Okay, Now, here's the tricky part. It might sound a little counterintuitive, but you got to remember, we are trying to come up with a number that divides into 36 and 54 evenly, okay? So the number that we come up with is going to be smaller than either of these two numbers, right? If your number is bigger than 36, it can't divide into 36. It's got to be smaller than 36, and it's also got to be smaller than 54, okay? So here's what we're going to do. Oh, no, I told a lie here. It's not 2 squared. It's 2 to the first. Okay, and that's important when I'm building my GCF. What I do is I take the min of the exponents on these prime factors. I take the minimum. So it's 2 power 1, 3 power 2. And if you do the arithmetic there, you get 18. Okay, so the reason we can't take the max, I know it might seem like, oh, you're doing greatest, so you should take the biggest. Okay, but you got to think about what this number is supposed to do. The number that we're creating is supposed to divide into 36 and 54. If I took the 3, well, 3 power 3 doesn't go into 36, so I can't use that. But 3 to the 2, that will go into 54. So you got to take the low. Okay, so take the lowest exponent when you look at your prime factorization. So you look at all the prime factors in each number and take the lowest exponent on any of them. I suppose we do need to be a little bit careful if one of these guys has maybe like a missing factor. So let's do a quick example where we do that. So let's try this. Let's find the GCF of not 36 and 54, but 36 and 84. Change things up a little bit. Okay, now I did the factorizations earlier. Well, we know what 36 is. That was just in the last example. 2 squared times 3 squared. 84. Let's look at what this is. 84 factors into 2 squared times 3 times 7. Okay, if you don't believe me, you can do a factor tree. Okay, so let's look at our GCF. Okay, so they've got 2's here, so my GCF is going to have a factor of 2. Now the question is, what exponent should I use? Well, I got to use the min, but they're both 2, so exponent 2. All right, now they both have 3's, so my GCF is going to have a 3. I got to take the min, so I take 3 power 1. This doesn't have a 7, so my GCF will not have a 7. If I throw in a 7, the number I create is not going to go into 36 evenly. And remember, it's supposed to go into both numbers evenly. Okay, so looks like my GCF is 12. Okay, so 12 goes into 36, right? 36 is 3 times 12. And 12 goes into 84. Let me see, what's the, I think it's 12 times 7 is 84. And this is the biggest number that goes into both of these guys evenly. Okay, so you get the prime factor method for finding the GCF. Write out your list of prime factors. Take the min of the exponents that appear on the common prime factors. Throw those all together. That's your GCF. Here's another way of doing it. It's called the Euclidean Algorithm. Okay, so this is a very step-by-step process. So let's use this same exact example here. So we're using the Euclidean algorithm to find the greatest common factor of 36 and 84. Okay. Now, with this method, the prime factor method, it's pretty easy for small numbers when we can get the factorization quickly. But if you got something bigger, sometimes breaking it up into primes can be tedious as well. But Euclidean algorithm, very step by step. So let's look at this. So we're going to fill in some blanks here. 84 equals blank times 36 plus blank. What times 36 plus what? Well, this is the quotient and the remainder, okay? So pretty easy to see that 2 times 36, that's 72. That's as close as I can get without going over. The quotient is 2, and the remainder is 12, okay? So 84 equals 2 times 36 plus 12. Now what I do is I shift everything over. So 36 equals blank times 12 plus blank, and now we fill in the blanks. Okay, well this is easy one. 3 times 12 plus 0. Okay, so when you get a 0 in this process, you stop. The last non-zero remainder is your GCF. So we can see, as before, GCF of 36 and 84 is 12. Okay, so very easy for dealing with larger numbers. For example, if we had a bigger set of numbers, find the GCF of 252 and 198. Let's do the Euclidean algorithm. 252 equals blank times 198 plus blank. Okay, well, I can only fit one copy of this in here. So 252 is 1 times 198 plus 54. Okay, there's the quotient, there's the remainder if I were to do the division. Okay, so we shift everything over. 198 equals what times 54 plus what? Okay, well 54 going into 198. Let me see. If I hit this with a 4, I'd be over 200, so that's too big. So let's go with a 3. Right? 3 times 54 is 162. And to get to 198 from 162, looks like I need a 36. Okay, so there's the quotient, there's the remainder. Shift them over. So here we have to do some extra steps, but that's fine. The Euclidean algorithm will take care of all this. Okay, so we can only get one copy of 36 into 54, so the quotient is 1, the remainder is 18. Now 36 equals 2 times 18 plus 0. So as before, once we get a 0 remainder, we stop. Okay. And the last non-zero remainder, that's our GCF. So the GCF of 252 and 198 is 18. Okay, so good thing about Euclidean algorithm, very methodical, very step-by-step, and it will get you the answer. It'll do the job. Okay. I did want to talk about one more thing, and that is finding the least common multiple of two numbers, the LCM. All right, So what I'm going to do here is, let's do a simple example. Find the LCM of 4 and 6. So, well, let's look at multiples of 4. The smallest multiple of 4 is 4 itself. 1 times 4. 2 times 4 is 8. 12. 16. 20. 24. ... Okay, multiples of 6. 6. 12. 18. 24. 30. 36. ... Okay, so you can see there are some things in common. The 12s are on both lists. 14 is on both lists. If I kept going with multiples of 4, I would get 28, 32, 36. Move out of the way. Okay. So 36 would be on both lists. Okay, so there are lots of common multiples of 4 and 6. The question is, what's the least common multiple? Well, the least common multiple of 4 and 6 is 12. Okay, so let's do that with a different pair of numbers. Find the LCM. Let's do 36 and 54. Okay, now we could do this the same way. We could just write out multiples of 36 and write out multiples of 54 and look for something that's common to both of them and find the smallest such number. But there's a quicker way, and it's related to what we did for the GCF, okay? It's the prime factorization method. Okay, so 36 is 2 squared times 3 squared. 54 equals 2 times 3 cubed. To find the LCM, you take the max exponent. Okay, remember when we were finding GCF, it was taking the min, the smallest, because we wanted a number that would divide into these things evenly. Here we take the max. So the LCM of 36 and 54 would be 2 squared times 3 cubed. And if you do the arithmetic, I believe we're getting 108, are we? Are we getting 108 there? So let's just take 54 and double it. Yeah, that's easy. 108, okay? So LCM of 108 for these two. Okay? So for finding the GCF, we're thinking you got the prime factorization method. We also got the Euclidean algorithm. For finding LCM, prime factor method. That'd be the way to go there.